Welcome to This Explainer. You know, it's wild to think about what happens when a literal Nobel Prize-winning genius tries to completely redesign how we learn, and then walks away thinking he completely failed. Today, we're deconstructing the educational philosophy behind one of the absolute most famous experiments in the history of physics. We're looking at the legendary Richard Feynman. But not just as a brilliant laureate, right? We're looking at him as an educator who tried to tear down and rebuild the traditional classroom. So let's just jump right in. We're actually going to start with a surprisingly humble confession from the man himself. This is about a course that is literally beloved around the world today, but he wrote, "I don't think I did very well by the students." I mean, the irony there is just staggering, isn't it? You've got one of the absolute greatest minds of the 20th century looking back at his own teaching and giving himself a failing grade? Why on earth would he say that? Well, to really understand why Feynman felt that way, we have to look at the tangible legacy he left behind, the famous Red Books. These were born out of a massive curriculum crisis at Caltech back in the early 1960s. These volumes, the Feynman Lectures on Physics, were the result of a grueling 4-year program to totally revamp their introductory physics course. The traditional way of teaching was basically broken, and the university brought in Feynman to reinvent the whole thing from the ground up. Which brings us to the first section, the problem with physics. Okay, so the core issue Feynman was tackling was that traditional education was, quite frankly, killing the enthusiasm of these incredibly bright young minds. I mean, imagine this. Caltech freshmen and sophomores are showing up on campus. They're brilliant, they're super motivated, and they are fired up about the grand, new, modern ideas, things like relativity and quantum mechanics. But instead of getting to the exciting stuff, they were slammed with a 2-year traditional curriculum, just endless sliding blocks down inclined planes and basic electrostatics. By the end of it, their enthusiasm was just completely drained. Feynman himself actually called this traditional approach quite stultifying. So, that set up the defining question for this entire pedagogical experiment. How do you fundamentally save the advanced student and actually maintain their enthusiasm? Like, how do you keep that spark of imagination alive when, at the end of the day, you still have to teach them the basic fundamental rules of the game? Section 2. Inspiring the brightest minds. Feynman's solution to this was pretty unorthodox. He absolutely refused to water things down. Rather than designing some basic survey course that catered to the lowest common denominator, he aimed his lectures squarely at the smartest people in the room. As he put it, he wanted, quote, to make sure, if possible, that even the most intelligent student was unable to completely encompass everything that was in the lectures. Think about that for a second. He's deliberately designing the material so that no single student could instantly master all of it. He'd constantly throw in suggestions of extra applications just outside the main topic, making sure the absolute smartest minds always had a new intellectual puzzle to chew on. Now, it's absolutely crucial to look at how he actually pulled this off. His teaching strategy prioritized deep physical insights over rote memorization. He'd meticulously point out exactly where every single equation fit into the whole body of physics. And he made this really clear, beautiful distinction between things you could logically deduce from previous knowledge and new, unprovable ideas that you just had to accept as a rule of nature. He was constantly pushing clever students to use their own deduction skills instead of just memorizing facts. Moving on to Section 3. The core and the fireworks. So you're probably wondering, in a massive lecture hall of 180 students with vastly different skill levels, how do you keep the average learner from just completely drowning? Well, Feynman engineered what he called a central core. Think of it as a backbone of foundational material. He knew not everyone was going to understand every single thing in a lecture, but he didn't want them getting anxious about it. If a student could just latch on to this central core, the main theorems and direct features, they'd survive and get the essential physics they needed. But then, layered right on top of that backbone were what he called the fireworks. These were the extra side applications and advanced deductions explicitly thrown in to challenge the absolute cleverest minds in the room. We're talking about material that your typical student probably wouldn't fully grasp until years later in grad school. But he planted those fireworks there for sure, just to guarantee the geniuses never had a chance to get bored. Which brings us to Section 4. Concepts before mathematics. Another totally radical piece of his philosophy was how he handled modern physics. He looked around and realized, hey, a lot of these students are actually going into biology or engineering, not pure physics. They couldn't afford to wait until their junior year to learn quantum mechanics, but they also didn't have the heavy math skills for partial differential equations yet. So he flipped the script. He used a qualitative method.
He introduced advanced concepts like energy levels and inductance purely qualitatively first, completely bypassing the intimidating math, with the plan to develop the complete mathematical framework later on when their preparation was actually adequate. But let me tell you, doing it this way was an immense high-wire balancing act. You have to remember, there was no textbook for this class yet. The students couldn't just go to their dorms and read ahead. As one student later joked, the lectures were incredibly exciting in the hall, but they turned into absolute Sanskrit the second they walked outside and tried to reconstruct their notes. And because Feynman was getting very little real-time feedback from a silent lecture hall, he was basically flying blind. Because of that lack of feedback, and honestly just running out of time at the end of the course, Feynman felt his attempt at teaching quantum mechanics was kind of a failure. In a really self-deprecating analysis, he admitted he simply needed more time to cover things like energy bands and spatial dependence. He outright said that if he had to do it all over again, he'd restructure it and teach it much later in the course. This leads right into Section 5, the ultimate teaching ideal.
Ultimately, Feynman did a deep philosophical reflection on the limits of the lecture format itself. And if you look strictly at how the majority of students performed on the exams, he judged his entire system to be a failure. He quoted the historian Edward Gibbon to highlight a really hard truth. The power of instruction often only really works on those students who are so naturally gifted that they almost don't need the teacher in the first place. True genius, he figured, often finds a way to learn completely regardless of the system.
But here is where it gets really fascinating. Here's the contradiction. Even though Feynman judged the experiment a failure based on test scores, decades later, researchers interviewed 17 of his former students. And get this, about 80% of them recalled his lectures as the most emotional, transformational experience of a lifetime. One student literally said it was like going to church. So it was this massive, inspirational success. And yet, despite all of that, Feynman still firmly believed that simply sitting in a lecture hall was never enough to truly learn. He concluded that real, genuine discovery only happens through a direct, individual relationship. It's that moment where a student and a good teacher sit down together, discuss the ideas, and just think through the concepts one-on-one. He completely understood that mass lectures are a reality of the modern world, right? We need them. But he always saw them as just a substitute for that ultimate face-to-face teaching ideal. Which leaves us with a really provocative question today. Feynman completely revolutionized the lecture format. He inspired millions of people through his red books, and he gave us an incredible framework for explaining complex ideas. But as we continue to heavily scale education through digital video and mass online courses, are we fundamentally missing that individual connection that Feynman believed was the true engine of learning? It's definitely something to chew on the next time you sit down to study something new. Thanks so much for joining me on this explainer, and keep questioning.